Well, hello, and let's talk about graphing parabolas or quadratics. Quadratics refers to the idea that there's an x squared in the polynomial. Hi, I'm David, and I'm going to try to give you some help on some delta math and some textbook problems. It's all about quadratics and graphing them. So let's start with some basics about a parabola. Can you find and sketch the axis of symmetry? And so we're looking for that reflection line. So I can see that the blue graph, the blue parabola there, is got a reflection left and right. And that reflection is over a vertical line where every x value is -2. Where every x value is -2. Remember, all vertical lines are x equal because every single dot, I could ask you, what's the x-coordinate there on all these dots? And you know what the x-coordinate is? It's -2. The y-coordinate keeps changing, but the x-coordinate does not. So a little memory on vertical lines. X equal -2 is the symmetry line. If you're on delta math, you'll choose what type of answer. So you're going to say, in this drop down, you're going to say an equation, and you will write x equal -2 when you choose an equation, or a line, I think it says, equation. Cool? Where is the vertex? Where is the vertex? Well, the vertex is the minimum or maximum of our parabola. It is the lowest or highest point. It's called a churning point in calculus. A churning point in calculus. And so the vertex looks to be this dot, and it's hard to read my screen on delta math. It's a little easier. But it's left 2 and down 1 xy's. So for this part of it, you will choose a point or 2 points, a point, from the drop down, and you'll put in that point -2, -1. Cool? Notice that the vertex is right on the same x value as the line of symmetry. That's kind of important. Connect that. All right, do you see any intercepts, specifically x and y intercepts? X and y intercepts. That's what we're looking for here. So do you see any x and y intercepts? Let's see. Let's start with the y-intercept. So y, I usually do int. The y-intercept is right there. I can observe it. It is +3 on the y-axis. So that's 0, 3. Again, for this delta, choose a point. Choose the point and then type it in. Do you see any x-intercepts? Actually, I see 2 of them. Again, I think you can choose 2 points in the answer type and list them both. So that was at -3 and -1 were the x-intercepts. Remember, intercepts are just where we cross the axes. X-intercept, y-intercept. Now, we've been talking a lot about translations. And this graph, this parent graph, seemed to move left 2, and down 1. Oh, look at that. What's the vertex indicate? Isn't that interesting? Cool. I hope you're catching that. So if I asked you to build the function like we did last period, it's a parabola that needs to go left 2 and down 1. Down 1, I just put a -1 on the outside. For left 2, it's x or plus or minus, and I kind of do a guess or a check here. So if I go left 2, I think it's x plus 2. And that's the actual equation for this function. So just a little extra there. We're going to talk about that more in the next period. So let's take a look at what happens with the textbook. The textbook says, well, I'd like to graph this quadratic equation, this parabola. Okay, graph each quadratic function is what the instruction says. It also wants you to get domain and range, which I'm asking you to always think about, and increasing, decreasing stuff. Cool? It also asks for the same types of information that we saw before on the delta math. You got an axis of symmetry, you got the y-intercept, the x-intercepts, things like that. Okay? So let's try to graph as much as we can. This is not a graph that is set up so I can do it with translations like left and right and stuff like that. So I'm going to have to graph this a different way. And that's what I'm going to teach you right now, or review maybe. Let's just get some intercepts. This is review. If I want to get the y-intercept, I make x0. So if I do x0, that's basically f of 0. F of 0 is, looks like if I plug in the equation, minus 0 squared plus 4 times 0, I think we get 0. 0. Okay, we have an intercept at 0, 0. X-intercepts. Oh, we got to remember how to do some algebra. Okay, this is going to be interesting. So y is 0. That's where the f of x is. So 0 gets substituted in. And this is what I'm staring at. Negative x squared plus 4x. So somewhere in algebra and advanced algebra, okay, we discussed as teachers, we kind of let you know that you can't do normal algebra here. You can't like subtract and divide and maybe even square root, plus or minus square root, because you would have to collect your x's first before doing anything like that. So this isn't like linear type of algebra or algebra where we can just undo actions. If you have a quadratic term and a linear term like we see here, quadratic term and linear term, you have to do something that is called basically quadratic algebra, which means we want to either factor it or complete the square or use the quadratic formula. I'm going to choose factoring because I notice that there's an x distributed. There's a greatest common factor of an x that's been distributed. If I undistribute it, I'm going to double check, negative x, yep, that's right, plus 4. I kind of distribute in my head a little bit. Does this check? Does this check? I always like to do that. And it does, cool. Now look, ooh, what x value makes 0? What makes 0? So x could be 0 here, that would solve this equation. Or I'd have to do what makes 0 with this guy. That's one of those tricky questions. I think it's positive 4. It is positive 4. You could check it if you like. So now I have an x-intercept of 0, 0, which I already had before, and 4, 0, and 4, 0. So these are my x and y intercepts. X and y intercepts. Cool. Now where's the vertex? Where's that symmetry line? Well, I know it's got to be somewhere in between these dots, because that's the beautiful thing about a parabola. Parabola has got that symmetry left and right. Even if the parabola is upside down or right side up, it still has that symmetry. So I can kind of see the symmetry lines at x equal, let's see, halfway between 0 and 4. That's where the 2 is. Yeah, definitely. So I've already answered one question or a couple questions. I've got the intercepts. I've got the symmetry line. Sorry. So what else? Where's that vertex? Well, I know the vertex is on x, that x equal 2 line. So I kind of gave away one possibility. The textbook examples will talk about a cool formula called negative b over 2a, where the a in this case is negative 1 because it's ax squared. The b is 4 because that's bx. And the c's is not really there, so it must have been 0. So that comes off the idea of ax squared plus bx plus c. Ax squared plus bx plus c. Kind of our standard quadratic formula. So if you take those values and implement this equation into this formula, you'll get the x equal symmetry line, or the x value of the vertex. So let's try it. X equal negative b, negative 4, over 2 times a, and a is negative 1. Okay? If you forgot about what ax squared plus bx plus c looks like, just kind of look that up. That's a good one to review. So negative 4 over negative 2. Oh, well, not surprisingly, that's positive 2. How do you get a y-coordinate? Plug and chug. Don't forget, if you have an x of 2, just plug and chug. Be mindful. Be very, very careful of all the order of operations that you have to do here. So it looks like I've got negative 4, because 2 squared, right? Plus 8. So it looks like I have a y value of 4. The vertex is at 2, 4. And that's using, I'm just going to go up there and call it 4 up there. And that's my vertex. Okay, the negative on the x squared, well, we've learned about that. The negative on the outside of our function does flip it upside down. So we now have an upside down graph through the vertex. That's our maximum. To answer the questions of increasing, decreasing, I think you're able to do that, but here's that turning point right here. So it looks like it's increasing up until x equal 2, like from negative infinity to 2 without a bracket. Increasing, decreasing does not use brackets. Cool? I think we've covered everything. Domain and range. Ooh, domain, all reals, no dividing by 0 or square roots. Looks like we come out of infinity for the range, and we stop at 4 with a bracket. The range can have a bracket, that's okay, but increasing, decreasing, do not. Do not. All right, let's take a look at the other delta math that you have to do this weekend. So we need 5 points, 5 points. And tell you the truth, 5 points are kind of the way you want to graph parabolas whenever possible. The 5 points you'll get, just a real quick idea, on any parabola, you're going to get the vertex. You're going to hopefully find a couple of x-intercepts. And then wherever that y-intercept is, that's a terrible vertical line, there's going to be a symmetry point, a corresponding point across from it. So the 5 points you want to get, vertex, x-intercepts, y-intercept, and then use your symmetry skills to get the dot on the other side of the symmetry line. So for this equation, first of all, if they throw a curveball at you and they put that negative in front, that does make it tricky. Here's what I recommend to do. Pull the negative out. Make it a reflection, an upside down thing, a flip down, and rewrite the rest of it. It's going to make your life a lot easier, and technically it's the kind of a more appropriate thing to do for part of this at least. Okay? Okay, so the vertex, the x-intercepts, the y-intercepts. Okay, so to get all these key points, you want to go ahead and plug and chug some just dots right around the vertex just to give you enough points. I think the x-intercepts are the way to go first. Let's get the x-intercepts. Let's set this equal to 0. So if you set this equal to 0, we have to remember how to break down these into binomials. So I'm looking at factors of 35 and hopefully, I think I found it, 7 and 5. Yep, 7 and 5. Remember, that's a guess and check game. We'll review that again a little bit more. So those are the factors that make this. So I got a what makes 0 of -5 and -7. Those are my two intercepts, -5 and -7. So I'm going to go to the x-axis and I'm going to put 2 dots there. You have to make 5 dots for this delta math to work. So let's get the vertex. Let's come back to the original equation up here and let's get the vertex. The vertex. If you've got your x-intercepts, don't be surprised if that -b over 2a comes out to -6, because look, the 2 x-intercepts kind of give it away that the x symmetry line is right in between and the vertex is on there. So go ahead and do the calculation, but you're going to find it's -6. Now we got to plug and chug a -6 and see what that's equal to. So I calculated f of -6 and it came out to a +1. So I plotted the -6, 1 point. Normally I'd say get the y-intercept in a corresponding point for our other points, for our last 2 plots, but the y-intercept's like -35. So let's just plug and chug -4. So I got -3. -4, -3 is plotted.